Something here on automated building extraction, but I go through it in the sake of time. And the main problem that automation fails comes from the fact that we have such a high variety, large variety of different buildings. There are some cases where modeling is relatively easy because we have repetitive objects, but other cases where it becomes very, very problematic. This is also a building which has to be modeled possibly. So this is a main problem where automated procedures are not intelligent enough and will fail. The main problem is really in image interpretation and automated control of level of detail, also to produce the correct topology. Look, if you look at this one, I don't know if you have done it in detail. This looks pretty good from your place. Huh? This is a 3D city model, but if you come close, like I do, then you see many, many problems. There are many houses which are in the middle of the road, so no correct topology. Okay? So how can a house be in the middle of the road? There's texture. The top of the building is being imaged twice, one times here, one times on the ground. There are houses which stand on cars, okay? So many, many problems, but it looks good from apart. It looks good from your place, but please don't go close. Huh? So this is the issue not only of geometry. The buildings themselves may be correct internally, but topology is totally wrong. And if you put it on a GIS, you cannot do any reasonable analysis anymore. Because topology is wrong, okay? So please pay attention also to topology. Another example, let me go through this one quickly. I've shown it on other occasions. We have now things like Google Building Maker, and people are talking about collaborative mapping, for instance, and they are producing things like this, okay? Look behind. I went to Google Earth and checked Taipei, and what I realized is you need a four-wheel drive in the city of Taipei. This is the DTM in Taipei. If you go to Google Earth, you know, in order to get up here with your car, you need a four-wheel drive, which I have in Switzerland, no problem. I'm prepared. Or here, this is Taipei. I know you know Taipei better than I do. I mean, we are far away here from the real situation. This is SIMT data, radar data, not good enough, of course. And this leads to the fact that some buildings are also swallowed. If you go to the Hyatt, some of us are in the Hyatt, you know, the lower part is chewed up by the digital terrain model. There's no entrance anymore. You know, and look at this feature, it's broken up. I mean, you can look around, you will find problems all over the place. So this has been done, I suppose, by a non-professional, by collaborative mapping. Do we need collaborative mapping? Do we want it? I don't know. In Europe, you wouldn't find any customer, at least not in my environment. If I present this data to my architects, they kick me out of the department right away. Okay? So please be aware of this situation. Then we have street views. Street views are very popular among young people. You know, you have this car, which I saw in Thailand, the Google Street car, taking thousands and millions of images, and then processing the data fully automatically. I used Photosynth, the software, Microsoft software, on this data set in Singapore, Malay village, and it returned a point cloud which is hard to understand. It is full of blunders. If you use a point cloud for modeling, you go nowhere, okay? Because you don't understand the structure. There are too many blunders, there are important points missing. So if you want to model this, you have to go back to the images and use image information for modeling. Point cloud is not good enough. This is what Photosynth gives you, automatically, quick but dirty. Do we want this? I don't know. The same applies to other cases. This is a photogrammetric block, and this is what computer vision people are using. 2.8 days of processing unstructured data as opposed to 2.5 minutes if you put a little bit structure into your data acquisition procedure. Unorganized, unstructured, as opposed to organized, structured. So problem of quality control pops up. What is the accuracy and completeness? Completeness is also important for the customer. If you get a contract for city modeling and you have to model 100,000 houses and you miss one house, you will have a problem with the customer, of course. So please don't forget about completeness. And also, one of the problems from a scientific point of view, we have very little or no qualitative and quantitative studies about the different techniques in house modeling. You hear many, many papers if you go to conferences, but who is comparing these different approaches? So far, nobody, but I would hope in the future it will happen. Okay, I think I have to jump to the conclusion now. I wanted to say something about UAV as well, but for the sake of time, I will skip it, and I will go directly to the conclusions. Sorry for that. First of all, when it comes to automation, where do we stand? Fully automation. And here I always like to quote Rodney Brooks, who is called the Pope of Robotics from MIT. He's a very famous man in robotics. And he published an article in one of our books in our school, The Road to 2030, A Wild Ride. And I quote from him, and he's addressing navigation, but we can apply it to the generation of city models as well. The robots of tomorrow will need to have the object recognition capabilities of a 2-year-old child, which is a very pessimistic statement for us when we think about automation. The robots of tomorrow, so we are not yet there even, will need to have the object recognition capabilities of a 2-year-old child. This is where we are in terms of image interpretation. A big, big problem, and the final frontier for any remote sensing person and any photogrammetry person, anybody who works with images. And the question is always, is it the problem based on measurement or modeling errors? Can you understand this one? Can your computer understand it? Probably not. Eh? Even for you, it takes some time to understand it, right? Okay, so the conclusions is we have a lot of tools available, a lot of sensors, and also software available for documentation, analysis, and dissemination. Sensors, processing software, visualization software, spatial information technology, internet finally. But the world also changes. We have to look more into the changes into 4D city modeling, for instance, with embedded attributes. And also the perception of the world and the perception of maps is changing. What is a map of the future? I could talk about this another hour here, but this is a serious issue of discussion. What is a map of the future, the 3D map? We also see changes in society and economy. We have totally new environments for research and development, education and professional practice. For instance, we see an increased interest in geosciences. When I came to Switzerland in '84, the geosciences were down, really down. They were discussing of getting rid of geology. In Stuttgart, they got rid of geology. Geophysics was down. Biology was dead after 5 years. You know, it was life, all of a sudden they called it life sciences, and then it was booming again. So now we have a lot of new interest in geosciences, triggered also by hazards, man-made hazards and natural hazards. By the way, from my understanding, there is no natural hazard. It's all man-made, finally. Okay? I can explain why. Nature is just nature, there's no hazard. But men are making mistakes, settling in the wrong places, underestimating the power of nature. You can, if you analyze all the hazards in the world, you will find out it's all man-made. It's not nature. So then communication, of course, we all know what has happened in communication, globalization of science, diversification, interdisciplinarity. And this has an impact on our profession. Now I talk about geomatics, of course. First of all, the inflation of data. How can we handle the inflation of data we are concerned with? The images alone. People say an image is worth 1,000 words. What will 1 million images tell us then? There's a term ubiquitous imaging, cloud-based computing and so forth. This is something we have to address. At our school, for instance, we have a Center of Imaging Sciences where about 25 professors from different areas, from chemistry, life sciences, geomatics, whatever, they're all concerned with images, one way or another, and with image processing. Go together and try to solve problems jointly. Increased system complexity, what does it mean? Does it mean we need more black boxes? Or does it mean we need better education? I don't know any black boxes, by the way, at least not in photogrammetry. Nothing works really automatically, except the production of an orthophoto, if DTM is given already. So I vote clearly for better and more education. Yeah, that's for me the only way to go. And the competition from neighboring disciplines. Everything is interdisciplinary nowadays. We are faced with people from electrical engineering, computer science, who aim to do the same things, to solve the same problems. So we shouldn't consider it competition, we should consider it a cooperation. Work with these people, whoever can contribute to our problem is welcome. But some of us are afraid, you know, we should be open. We should be aware of our own capabilities. We do have things which others cannot do, very clearly, okay? And we should put these into the cooperation. And also maintain depth in research. And just I've seen applications for professorship where the guy wrote, I know how to handle software A, software B, software C. This is not a qualification for a professorship. To be able to handle a software, okay? If he knows what's inside the software, then he's closer to professorship. Okay, so this is maintain depth in research, don't be too flat. So finally, I'm over time a few minutes already, and this is, by the way, from Mongolia, a fantastic place out in the countryside. And I wish all of you who go back today or tomorrow a nice journey, and see you all in Thailand next year. Thank you very much for your patience.
Yes, I wish to thank the two white elephants in the Asian sense. Now we have the coffee break, and please come back at 10:30 for the closing ceremony. Thank you.